Okay, well, welcome back to the little black box stuff. Yeah, so I haven't made a video in a long time, a couple months. I'm running a through-hole version, 1.1 right now, and I'm running test code right now. It's going to be post 105. But I just kind of wanted to give an update to a lot of people that may or may not understand, you know, what this is and how it works. So a real simple thing is the Lil Blackbox is actually an Arduino shield, and you have to run code on the Arduino. This is news to some people. So you have to have an Arduino. It's the actual processor that does everything to compute, you know, shaft speed, pin positions and all that kind of stuff to actually send the position to the turbo of what it wants to be. So you got to have an Arduino. Secondly, there's a lot of code, and for people that may or may not understand code, it's okay. The stock code that I have, the common code that's on the forum, it's just for basic people to kind of understand. You know, I can just upload that to the Arduino and it's just going to work. Now on the Arduino itself in the back, this is, I don't know if this can actually show up in there, but on the back on the left, there's three little jumpers, and depending on the position of those jumpers, which is on the Wiki, tells the controller what curves to use for the turbo. And right now the code is just set up basically for a Cummins i6. So mine's a P pump, and that's what I've been coding against, but it's been working on some other guys' 24 valves. I don't know if anybody's running a 6.7 yet, but right now it's running on a 5.9, and I can't tell you because I don't have a vehicle, but if you have like a smaller motor, you might actually need more aggressive curves. But the code is very simple to actually adjust, and I'm, you know, totally available to help people out write code, or they can post it on the forum. We can help edit, you know, stuff to make private curves for their turbos on their vehicles. And so I wanted to also kind of show people that turbo shaft RPM is extremely important for the VGT. You can't just go off of back pressure. It'll work, and you'll think that like maybe this turbo is kind of cool, and then you'll feel later, probably the longer you have it on there, just running off back pressure, that's kind of a poopy turbo. It's got no top end, you know, response is, you know, pretty good, but it doesn't seem to go anywhere. Or, you know, you got to sit there and listen to your exhaust with a all day, like it sounds like a hairdryer turbine trying to take off, because you can't really figure out what to do with the turbo. Like, you need to know what RPM it's at. It's very, very important. And like right now, I've been setting up, this isn't on the current code yet, but excuse the monitor with the lines. It's idling right now. Like, I added in this Boolean so it knows that it's idling, and when I step on the throttle here a little bit, you know, the turbo's going to come up, it's going to go into normal operation mode, it's going to be cool, everything's great. Now, with the code that it is right now, it's really aggressive to get the turbo up and spinning, and then it lets off on the position. And you can't see it because it went so fast, but it actually went, you know, like 5 centimeters, and then it immediately opened back up. And you couldn't tell, maybe in the video, the sound of the turbo or anything like that. You can't even really see it, like on the boost gauge over here. You know, this is, you know, a compressor one. You gotta give that one up. But as soon as I step on the throttle, it starts rolling. That's already 10 pounds of boost. So what happened over here is shaft speed increased a lot. It went from 10,000 basically to 30,000, but in between that, you know, let's just say you went off of back pressure. Well, you know, there may not be a lot of back pressure right now. Who knows? You know, it's not very stable either. So if you went off of back pressure only, I'm gonna put it in here. I'll show you. I'm gonna put it in brake mode right now. Okay, it says spare, but it's actually brake. You can hear it. I have the Boolean set up wrong. Okay, now the boost gauge really hasn't moved much. Okay, so there's no brake, and then again the brake. And I'll try to get my RPM on there so you can actually see it kind of drop a little bit. Okay, so let's say I'm going off of back pressure only. Okay, and this is basically position 940. So I step on the throttle. Now boost is going to increase a little bit. Okay, but you hear a lot of turbo whine, like it's whining. Okay, but it's still only 10 bounds. So look at my RPM. My RPM is still about the same. Let's drop it out of brake mode. Now it's still maintaining the same amount of boost, but my RPMs actually went up. Crazy, isn't that? What's the correlation between that? This is why shaft speed is so important for this turbo. So I'm gonna drop it back into the brake, okay? Now, I'm gonna show you shaft speed over here, keep my throttle the same, okay? So it's 34,000, 35,000 RPM. I'm gonna drop out of brake mode, okay? Still the same shaft speed, way open position. Now one has to think, well, I don't understand. Why is this the way it is? I don't know. This is how VGT works. So you really want to know shaft speed. You know, you can figure out other ways to put it on a shield or whatever and do your Arduino thing. You can make it in a tiny box, whatever. You don't have to buy my crap. But I'm just showing that you really need to know shaft speed on a turbo. It's just integral to knowing what to do and how to position it so that it's in the optimum running position. So generally just running around, you know, 940, which is like basically 3-4 centimeters, to try to spool up the turbo, it's just never gonna happen. Like, here, I'll just roll the throttle. There's eventually a point at which I just, you know, like I have to give it so much throttle. Watch when I drop it out. You know? It's ridiculous. Shouldn't have to have that much throttle to just get the turbo to spin. You know? Okay, so on 15 pounds of boost, 1900 RPM, 60,000 on the turbo. Drop it out. I lose 10,000 RPM on the turbo, and I only lose like 2 pounds of boost. Again, still not efficient to run it that way. So you need to make curves depending on shaft speed of like how your motor responds to, you know, basically choking it. You know, that's the best way to describe it. Changing the size of the turbo to meet the demands of the motor. So I'll try to maybe make a little video here of me driving it for some guys to understand. I'm on a curve that's not even on the code right now. This one's extremely aggressive, just for fun, because I have my boost gauge. I wanted to see, you know, what I could do. And I'm doing a lot of ass dynoing on it, you know, when I can feel like same throttle position, but I feel the turbo choke the motor, and I kind of feel like I actually decelerate for a second. Then, you know, I go back and I tune the curve, you know, open it another centimeter or half centimeter. So hopefully I can make a still video of like some basic driving for this, but it's kind of difficult to do this. My neighbor wants to pull out without looking. Come on. Hi, Joey. So basically with this curve that I'm running right now, I generally almost always have 10 pounds of boost. Generally. Turbo sounds good. Motor friggin' loves it. Oh, thank you, son, for... I think I'm gonna have to turn around and get shade on the gauge so you can actually read it. And turn it around. maybe I get it right about there. There we go. This is third gear. And I'm really not even playing with the throttle. I'm not mashing it. I'm just kind of actually just driving the truck. Put my foot in it, I'm gonna lose my clutch again. That was like half throttle. The truck's breaking loose in third now, it's just accelerating. And no, I don't have like 35-inch tires. They're 265/75s on 16s. So. This comes out pretty good for some of you guys. I'm gonna pull over here. Let's get in some shape. So yeah, you know, $25 Arduino. You know, a little time and wiring it up. Mine right now, it's 2 wires are for the CAN bus, which is high and low. 2 wires are for the VR sensor. It's just actually a magnet on the turbo. And then 2 wires, of course, power and ground. And then I have 2 other wires right here for my switch. And these are, like, I don't really need a performance mode, but top one is my brake. And the bottom one I use for setting it to cruise. Now cruise is cool. The code that I've written for cruise is to try to keep the turbo just right around 50,000 RPM. That gets it on the compressor map, so you can read it. I think it's like a HX40 or Super for the compressor map. But then, you know, at least you have like 5-10 pounds of boost when you're driving around like on the freeway and stuff. But then you put your foot on it, you know, you get nothing. So it's basically just, you know, to maintain hills and grades and stuff, you know, mostly flats. But that way it gives you the ability to, you know, get some MPGs out of your truck with this turbo, because there's no reason to have the turbo always in aggressive, you know, vane positions just because. So, you know, you have the opportunity to put that in there. And like if a guy's got AMS or Mega Squirt or anything like that, you can just wire up those switches to any kind of ground. They're all set up on the board as grounds. The spare is actually software configurable, but everything else, like performance modes, brake mode, and cruise mode, they're all with manual 10K pull-ups on the 5V rail. So they're safe to, like, that's why I don't even have these covered. I don't really care. Nothing bad's gonna happen. Even if they ground out, like, that's just switch on. So it won't actually damage anything. So you can set those up, pins, in your software. Like if you know, you have a whole standalone, you could say when your throttle is completely off, you know, you're at cruise mode or something, you know, or if you even have like a VSS miles per hour sensor, you could set up to go to cruise as particular TPS and vehicle speeds. That way, you know, you get MPG out of your vehicle, and then if you know, throttle plus 75%, you want to make it performance mode, and then it just really kicks the turbo in the butt and gets it rolling fast. So there's a lot of opportunity out there for making all sorts of cool stuff with this thing. There's room for 3 analog digital converters on the back. That's 5 volt for anybody that doesn't understand. You use a 5-volt sensor, you can program it any way you want. You know, like a boost sensor, most of them are 5-volt. Back pressure sensor, so you still use just a boost sensor for that. You can run TPS. You could do some square wave counting and stuff too on the pins if you wanted to. So I hope this is really informative to a lot of people. And if you're interested in them, it's lilbb.com. So enjoy, guys.